We've been going through different types of safety circuits to understand troubleshooting them, and one clear advantage of the CR30 configurable safety relay is that in addition to it being well configurable, is you can get it with the Ethernet option on front of it. And while we can't really do Ethernet safety with the CR30, we can get a lot of good diagnostics information. So in this video, we're going to diagnose it with Connected Components Workbench. And while I'm using Developer Edition, you can use the free version of this. And if you're not sure how to download Connected Components Workbench, then check down in the description. And we have a course that goes through all that. And go ahead and hit that subscribe button and tap the bell. Let's go ahead and create a new program, and you can do that from the start page, or there's an icon here, or simply go File, New, and I'll just stick with Project 5. And then instead of even going through here and trying to find it, we're going to select an existing device. And then let's go find our safety relay. And if you're not sure how to configure your communications, then in that course down there in the description, it'll walk you through all of that. But I'm going to select it and click OK, and we're going to add it to project. And we see it over here on our left pane. We're going to double click on it, and now it is incredibly important that we understand the difference between upload and download. We upload from devices. We download to devices. It's the opposite of the internet, and I had somebody in my Part 2 class the other week. I don't know why I never thought of it, but remember this. Upload equals uptime. Download equals downtime, because you're going to take your machine down. So we want to hit the upload button, and then we will have to go find it again, and that is going to pull that logic out of that device. Now it says upload and replace current project's contents, and we want to do that because we have a blank program here. And now we can edit its logic. Now, I know it seems a little awkward. We're not going to actually edit its logic, though. We're actually going to view its logic with the Edit Logic button. And in here, we can see all of our safety items. Let me close this up a little bit. Let's see if I can zoom. Oops, I don't think I have a zoom in this. View. Nope. At least I can find my zoom really fast. So I'll just have to use my scroll bars. But all right, we have an e-stop 1, and we have an e-stop 2. And if I press my e-stop, then we get a really clean graphical interface across here of why it's not working. Pull it back out, and we can see here it's flashing over here now. And if we work our way over a little bit, we see our reset is SMF7. Now what I'd love to do is be able to right click and go to SMF7, but I don't know how to do that. So we're going to go over here. And we need to go down and we need to find SMF7. We scroll down and there's SMF7, and that is looking for EI10. Now, EI10 correlates to the numbers on the terminal blocks, and it's not necessarily that they're on the top at their input and bottom at their output, so pay attention to them, but the bottom ones go from 12 to 21, and the top ones go from 0 to 10. And I have a wire coming off of 10, and that is going up to our reset button. So when I press the reset, we see SMF7 illuminate. And notice I held it too long because I was trying to explain it to you. And so it gives you some really good tips here. A transition of the reset input from on to off did not occur within 3,000 milliseconds or 3 seconds. So this is where you have to be really intentional with your actions on a safety system. That could simulate an operator who's frozen, and we don't want them to do so. But we're seeing it now, and when I press the button here, we see that goes solid. All right, now let's talk about troubleshooting some of those same scenarios that we did with our safety system. So if you recall, switch 1, that's going to break one of the contacts on our emergency stop. So on the back of our safety relay, it has 2 sets of contacts for these redundant setups. And we had a single contact over here on our older MCR setup. And so what switch 1 does is it pretty much simulates this contact getting broke off or being stuck so that we only have the one contact actually operating. And I'm going to press my e-stop. And right away, we get discrepancy fault. Input channels inconsistent, greater than configured discrepancy time. So there is a certain amount of time if we go into an advanced here. And so it says 50 milliseconds times 2. So we give it 100 milliseconds to manage to switch both contacts. And I love the graphical interface here because it's telling us the EI00 is off and EI01 is on. Now here, similarly to when I was talking you through troubleshooting this is the hard part about safety is we're always thinking, well, I need the thing to run. But remember, a safety system is designed to safely stop the machine. So if it doesn't think it safely stopped the machine, it won't re-energize. So when we're checking this, we need to think about it with the e-stop pressed. And we can see here that, yeah, E01's the issue because this should be broken right now. That's what it should look like. But yeah, very nice graphical interface. But now we're going to try to reset it. And we remember we had that SMF07 going to that blue button. But that reset that we were looking at, that is to reset this safety output. That is not to reset this. So in order for this to reset, it's going to have to see the true to false transition and back to true of these two inputs within its discrepancy time. So now if I pull the e-stop out, press, we can see it's getting a good transition now. And that will give us our reset. Now the other common failure we talked about was a welded contact on this system. And so that is switched to. So the operator presses their e-stop, and we saw this one did drop out, this one did not. And if we look into our program, then we see we did get a good e-stop. There's no red here, and that is going into this and that is going on through here. And notice at this very moment, there's nothing really glaring at us saying, hey, we need, we have a feedback problem with one of our contactors. It's going to make us fix this piece first. So I'm going to pull my e-stop out, and that's going to get us over to here, and everything's looking good. We press our reset button, and we're not getting anything. So it says our feedback will be on SMS3, and our reset will be on SMF7, and we have a manual type of reset. So we need our feedback first. And what does it look like when we have good feedback? Well, we switch this switch here. And we see now it's green and it's flashing. So the fact that it was sitting here gray, that means that we have a feedback issue. So we're looking for SMF3. Now still, I would love to be able to right click here and find it. But if we go over here on the left side and we go down, here is SMF3. And it says it's coming from P2_00. If it is actually a safety output or a safety input, it does have to be on the CR30. Now, the feedback circuit can be on a regular input. So P2 means plug-in module 2, 00 is input 0. So we are actually taking our reset to our plug-in module. We could take it to this too, just mainly showing you different things you could see. So we'll fix our feedback circuit. That's going to give us green on this one. We see it flashing up here. SMF7. That brings us back down here to our reset. And yes, I'm going to let it go red the first time just so I make sure you see it as I'm going to press and hold that. And that is our reset button. Again, we got to, everything there's specific timing on that is laid out by TÜV Rheinland or whichever standards organization you're using. So we'll press it properly. And that'll let it back go. Now, there is a really important troubleshooting tool on the CR30 that I almost never see used because as cool as it was that we could go in and troubleshoot this through Connected Components Workbench, we didn't actually need to. There are some LED indicators on the front of this that you'll almost never see on your systems. But these are all configurable for different things. So if we look into our program and we go back to our Guard Master, the main tab, Down here we have LED configuration. And so this can be used for lots of good things. So I have set this one up for terminal 0 to be terminal 0 status, coincidentally, and through 3 to be 3s. So what are 0 through 3? That is these e-stop inputs. So this way, by looking at the front of this relay, I'm going to tell what's going on. Next, we have SOF is number 4. That corresponds with the SOF1 over here. So this will let us know if we're telling the relays to turn on. Then we have our safety monitoring function status, and that is SMF 3, 5, and 7, and then SOF function 5. And those are the ones we just went through down through here. So by having that, I can see right now that we're lit up through there, but if I press my first e-stop, that drops out 0 and 1. Also dropped out my safety output. Pull it back out, and we're good now, but it's waiting on a reset. So that can be a really fast way to glance over and figure out what's going on without even having to connect with Connected Components Workbench. So set up those LEDs, and also we can actually set this up in the I/O configuration of Studio 5000. And I've created this playlist right here that includes that video.